Hello everyone, and thank you for attending today's webcast on IDT's RF technical innovations. Before we begin, I'd like to cover a few housekeeping items. At the bottom of your audience console are multiple application widgets, which can be used during this event, as well as if you're viewing the webcast on demand. Please use the Q&A widget to submit your questions. If your question is not covered during the event, then your question will be answered in full via email. There's also a survey widget at the bottom of your console. Please take a moment at the end of this event to provide us with your feedback. Your participation is greatly appreciated. We are joined by Baljit Chandhoke, Marketing Manager for RF Products at IDT, who is going to talk to us about IDT's latest RF technology. He has over 15 years of experience in the semiconductor industry, working with customers to understand and overcome design challenges and define new leading-edge products. Baljit, thank you for joining us today. Can you tell us about these latest innovations from IDT and how they help RF system designers?
Thank you, Chris. Today, I'm going to focus on the latest technical innovations that IDT has in RF technology. With these unique technical innovations, we have been able to bring to market highly differentiated RF products, which have up to 10x improvement in RF performance. At the end of this presentation, you will be able to explain these technical innovations from IDT and understand how these innovations help system designers solve their technical challenges. These innovations that we will talk in this webcast are Glitchfree, flat noise, zero distortion, KZ or constant impedance, Kailyn or constant linearity. Now I'm going to talk about the Glitchfree technical innovation from IDT. Standard DSAs have sharp 10 dB glitch, which occurs during MSB attenuation state transition. As you see on the slide, going from minus 11.5 dB attenuation to minus 11.25 dB attenuation, there's a huge glitch. And due to this glitch, the attenuation changes, which might cause damage to the downstream devices, the power amplifiers. Also, the settling time to the next attenuation stage is large, with greater than 1 microsecond, due to which the TDD turnaround time degrades. With IDT's glitch-free technology, we have been able to eliminate this glitch, and for the same MSB transition, we only have 0.5 dB change in attenuation, and the overshoot is 0.5 dB, and we settle within 350 nanosecond. So the benefit of IDT's glitch-free technology is there is no chance of damaging downstream devices, so the reliability of downstream devices improves, the TDD system agility improves, and the overall quality of service is improved. Another unique technical innovation from IDT is flat noise. Noise figure is a figure of merit for RF devices. With high intermediate frequency variable gain amplifiers, as you reduce the gain of the amplifier, the noise figure degrades. As you see on the slide, for a standard VGA, going from 20 dB attenuation to 16 dB attenuation, the noise figure degraded from 8 dB to 12 dB. Going from 20 dB to 12 dB gain, the noise figure degraded from 8 dB to 16 dB. So there is a dB for dB degradation in noise figure as you reduce the gain of a variable gain amplifier. Now, as you know, this is not good because you're degrading the system signal to noise ratio. With IDT's flat noise technology, we are able to maintain the noise figure almost constant. So as you see on the screen, going from 20 dB gain to 12 dB gain, IDT's noise figure of our variable gain amplifiers only degrades by about a dB. So it goes from 4 dB to 5 dB. So effectively, we are able to keep the noise figure virtually flat in the critical region while the gain is reduced. This greatly eases design constraints for radio engineers by enhancing the system signal-to-noise ratio. Another unique technology from IDT is zero distortion. This technology is used in mixers, and with zero distortion, in a crowded spectrum, we are able to reduce or even eliminate third-order intermodulation distortion products. So they're greatly reduced, as you will see in this. So I'm showing you an example in which this is a standard mixer where your region of interest, your frequency spectrum 1855 to 1860, has huge third-order intermodulation distortion products, due to which you have issues in terms of system performance. With IDT's zero distortion technology, we are able to reduce these third-order intermodulation distortion products by 83%, as you see on the slide. This enhances the system quality of service, improves coverage, and frees up underutilized spectrum. Another unique innovation from IDT is KZ, or constant impedance. This technology is used in switches. When you are switching from one RF port to another with constant impedance, we are able to keep the impedance almost constant. So it does not change. And the benefit of this is that your return loss does not degrade and your voltage standing wave ratio remains almost same. Some benefits of a constant impedance switch are: when hot switching an RF amplifier, you do not get huge voltage standing wave ratio, as you see on this non-KZ switch. At the time of switching, it creates a large voltage standing wave ratio, which might cause damage to the downstream devices. With IDT's KZ technology, as you see on the slide, the voltage standing wave ratio remains almost constant. The return loss does not degrade. Also, when you're RF pulling, switching between different VCOs, with a KZ switch, the frequency synthesis error is extremely small and the settling time is fast. Whereas with the standard switch, you get a huge frequency synthesis error and the settling time is also large, as you see on the slide. Also, the benefit of KZ switch, constant impedance switch, is reduced phase and amplitude variations of non-switched paths in an RF distribution network. Now I'm going to talk about Kailyn, one of our very recent technical innovations. With Kailyn, we are able to maintain high linearity as gain is adjusted. So to explain this, I'll show you a plot. Here, as you reduce the gain for a device without Kailyn, the IP3, or the linearity, degrades as you reduce the gain of the device. With IDT's Kailyn technology, we are able to keep constant linearity or constant IP3 as we reduce the gain. So as you see on the slide, going from 30 dB of gain to 25 dB, our IP3 remains constant. Whereas for a competing device without this feature, there's a degradation of almost 4 to 5 dB as you reduce the gain by 5 dB. Another benefit is we are able to provide you MSL1 versus MSL3 for competing devices using gallium arsenide technology. So IDT's technology, which we use silicon-based technology, which I will cover in the next slide, enables us to provide you this benefit of better reliability as well. Now that we have gone over IDT's unique technical innovations, let's talk about the unique value proposition IDT has with our RF products, which enable us to provide highly differentiated solution to our customers. IDT uses silicon-based technology for our RF products. Due to using silicon-based technology, we are able to provide you high reliability, low power, and silicon-based technology is a replacement to a traditionally used gallium arsenide technology for RF products. Combining this with our unique technical innovations, Glitchfree, where for a DSA, we were able to keep the same, eliminate the glitch when changing very small attenuation step at the time of MSB transition. Flat noise, where we were able to keep the gain constant or noise figure constant as the gain was reduced. Zero distortion, where we were able to reduce the intermodulation distortion products. KZ, where at the time of switching, we had constant impedance. And Kailyn, where we had constant linearity as the gain was reduced. These technical innovations and silicon-based semiconductor technology from IDT enable us to provide highly differentiated products to system designers to solve the challenges of having systems with low signal-to-noise ratio as well as high linearity. Now I'm going to cover some benefits of replacing gallium arsenide with IDT's silicon-based technology. In this slide, some inherent advantages of silicon-based technology are shown where we only have one component for a DVGA, whereas for a competing device using gallium arsenide, there are 20 components. Due to this, the manufacturing robustness is better, ESD performance is better, RF performance is better, there's improved reliability and lower solution cost. Whereas for a competing gallium arsenide solution, you get the lower manufacturing robustness and average RF performance and worse reliability. Now I'm going to talk about our portfolio of devices which uses these unique innovations that we've talked about. These portfolio of devices include RF switches, amplifiers, DSAs, mixers, IFVGAs, integrated receivers, modulators, RFVGAs, voltage variable attenuators, as well as integrated DPD demodulators. In all of these products, we are providing you high reliability, better signal to noise ratio, faster settling times, eliminating glitches, as well as third order intermodulation products, reducing power consumption, and higher operating temperature. With our unique innovations, we have products with high linearity, high reliability. We have switches which have isolation over 74 dB. We have wide bandwidth products, and we have products with go up to 9 gigahertz. And these products are good for wireless infrastructure market segment, industrial market segment, CATV broadband market segment, test and measurement, and microwave and RF market segments. Let's talk about the CATV broadband market segment. There is a new inflection point with DOCSIS 3.1 in this market. As you see on the slide, with the demand for consumer data rates increasing and DOCSIS 3.1 requiring better RF components as it has to support 10 gigabit per second downstream data and 1 gigabit per second upstream data, IDT's RF technology and innovations enable the need for the CATV market segment. As you see on the slide, cable head end where all the cable data is aggregated, fiber optic network which is used to distribute the cable data with optical node amplifiers and line extenders, finally coming to the cable box and to your home. All of this requires a lot of switches. attenuators. And IDT has products like I've shown on the slide, F1975 and F1977, which are DSAs which are in production for this market segment. On the customer premise equipment, there's the set-top box, the DOCSIS 3.1 modem, the switch, which all need switches. The IDTs, all of these products that we saw in the previous slide require 75 ohm for CATV. IDT's products for this market segment have 75 ohm impedance. So the 1975 6-bit DSA has glitch-free IDT's technology that we talked about and has IP3 of 64 dBm. With this, we are able to provide you the lowest insertion loss for best signal-to-noise ratio, ultra-low distortion, extremely accurate attenuation levels, and the glitch-free technology protects power amplifiers or ADCs. The 1977 has similar performance and has a step size of 0.25 dB. Both these devices are production released. Now I'm going to talk about a base transceiver system. What we have shown on the slide is a block diagram of a base transceiver system. As you see on the block diagram, there are DSAs, there are mixers, there are dual mixer, there's a dual IF-VGA, there's demodulators, switches. So what we have highlighted are IDT's products using these unique technical innovations we talked about earlier, and all of these are in production, which are in blue. We also have integrated products where we have combined many of these blocks together, as you see with this Model A F0552 device. One of our new family of devices is the Versa Mixer family, which was launched on April 7th, 2016. With this family, we are providing a totally versatile solution to our customers with ultra-wide bandwidth, ultra-low power, and configurable gain settings. With the Versa Mixer, customers are able to have any operation from 400 megahertz to 3800 megahertz with a single bill of material. The Versa Mixer uses IDT's flat noise technology, where the noise figure remains constant as the gain is changed. It uses zero distortion technology, where IP3 is 35 dBm at 2.6 gigahertz. The Versa Mixer family has two products, the single channel mixer and the dual channel mixer. Samples, evaluation boards, parts are all available, and the device is production released. Some key features: the RF frequency range for Versa Mixer is 400 to 3800 megahertz. The intermediate frequency range for Versa Mixer is 50 megahertz to 600 megahertz. The noise figure is 8.7 dB to 10.7 dB depending on the settings, and the IP3 is 34 to 40 dBm. There are four gain settings, and the channel isolation for the dual channel Versa Mixer is greater than 45 dB. Some key applications for Versa Mixer are in point-to-point in base stations, microcells, industrial applications, point-to-point microwave backhaul systems, broadband repeaters, public safety infrastructure. Another device family we have is digital step attenuators. The digital step attenuators use the glitch-free technology from IDT. We have great linearity with third-order intermodulation distortion of only 65 dBm, and the step error is 0.08 dB, and absolute error is 0.2 dB for our digital step attenuators. There's a huge portfolio of devices, as you see on the slide, and we offer a solution for both 50 ohms and 75 ohms. As an example, we saw for CATV 75 ohms was used, and we have devices meeting that requirement. The resolution is 0.25 dB and 0.5 dB, and the attenuation range goes all the way up to 31.75 dB. The package is extremely small with 4x4 24-pin package or 20-pin package. Insertion loss of 1.2 dB, and the resolution 6 to 7 bits. We also have voltage variable attenuators, which provide ultra precision high linearity. With our VVAs, we have low distortion with an IP3 of 65 dBm, which enable us to have almost 1,000 times better linearity than gallium arsenide technology products. Insertion loss is small with 1.3 dB, and the frequency range goes all the way up to 6 gigahertz. With a VVA, the characteristic is linear in dB, and we can offer you devices with both positive or negative slope. We have our high reliability switches, which provide high isolation, low loss switching. With our switches, we use the constant impedance technology, and our switches go all the way up to 9 gigahertz. Isolation is 74 dB, and insertion loss at 2 gigahertz is 0.41 dB. With the constant impedance technical innovation from IDT, we are able to maintain the return loss when switching. IDT switches are ideal for applications requiring low insertion loss and high isolation. This slide shows you an example of our KZ, or constant impedance switch. It's a SP40. So we have switches which are SPST, SPDT, SP40, SP5T. And as you see, the isolation, even though it's a 4-tap, is still 50 dB. Return loss is 16 dB, and IP3 is 61 dBm. The switching time is fast with 250 nanoseconds, and the device is production released. Our intermediate frequency variable gain amplifiers improve signal-to-noise ratio with the lowest noise figure, and with our flat noise technology, the noise figure does not degrade with reduced gain. In summary, IDT has unique technical innovations which enable us to provide you with highly differentiated products with up to 10 times improvement in RF performance. With our glitch-free technology, we are able to provide you DSAs which do not glitch. With our flat noise technology, we are able to provide you devices with constant noise figure as you reduce the gain. With zero distortion technology, we are able to provide you devices with 90% reduction in third-order intermodulation products. With KZ technology, which is ideal for hot switching, we are able to provide you switches where there's constant impedance during switch transitions. And with Kailyn technology, we are able to provide you RF devices which maintain linearity as gain is adjusted. All of this technology is unique to IDT, highly desired by equipment vendors, and protected by patents.
Thanks, Baljit. Now, could you elaborate on the reliability issue, especially comparing your devices to a gallium arsenide device?
A great question, Chris. One of the key things that IDT has is the technology that we use. We use a silicon-based technology, which has great benefits as compared to the traditionally used gallium arsenide technology for RF products. Now I'm going to highlight some of those benefits. As you see on the screen, as an example, we have a DVGA from IDT, which only has one die, and we compare this with a DVGA from a gallium arsenide-based product, and as you see, there are 20 components. With these 20 components, the reliability is extremely poor. In addition, your manufacturing robustness is poor. Also, the RF performance of gallium arsenide-based product is not that great, especially in terms of insertion loss and IP3 performance. And because there are 20 components, the solution cost is also high. Now, if you look at the IDT silicon-based technology, we only have one component for the same functionality, which enables us to have higher manufacturing robustness, better RF performance. We talked about the IDT's innovations, technical innovations, which allows us to have better RF performance, improved reliability, and lower solution cost. So we believe IDT silicon semiconductor technology has inherent advantages which are reflected in our RF products.
Okay. And then you also mentioned that the zero distortion technology reduces intermodulation distortion by up to 90%. How important is that to RF system designers, especially as they are constantly trying to squeeze more and more out of the spectrum they have?
Again, great question, Chris. In terms of today's technology, one of the key things that customers have is the spectrum and how they can utilize the spectrum effectively. So with IDT's zero distortion technology, we are able to reduce the intermodulation distortion products, which enable our customers to free up the spectrum and have improved coverage with enhanced quality of service. So as you see on the screen, there are intermodulation distortion products which standard mixers have, which cause interference in the spectrum of interest. Due to these intermodulation distortion products, the spectrum is not used effectively and the quality of service is poor. With IDT's products, we have reduced this intermodulation distortion by up to 90%. And as you see in this particular example, the peaks are lower and we are able to provide you more effective utilization of spectrum. So zero distortion technology from IDT is key for crowded spectrum and enables our customers to have greater utilization of the spectrum.
Okay. Now we had the Versa Mixer evaluation board in our lab and the opportunity to play around with that and test out some of its features. So we're going to show you that video and then we'll come back for the audience questions. I'm Chris Anderson at the EEWEb Tech Lab, where today we'll be looking at the IDT Versa Mixer. Versa Mixer is a wideband, low-power mixer available in single or dual-channel configurations. It can cover RF and IF bandwidths of 400 MHz to 3.8 and 3.6 GHz respectively using a single BOM, letting RF designers deploy the same mixer across a range of technologies. The mixers feature IDT's flat noise and zero distortion technology. Flat noise keeps the noise figure virtually unchanged as gain is reduced from its maximum setting, giving designers more flexibility by providing the best SNR possible. Zero distortion reduces third-order intermodulation distortion by approximately 90% to improve coverage, quality of service, and spectrum usage. For the demo, we have the evaluation board with the dual-channel mixer, but we'll be using it with just a single channel, so I'll hook that up and we'll get started. So at the center of the board, we have the Versa Mixer IC. We have the RF inputs for both channels, the IF outputs for both channels, and then the LO input. This is just the DC voltage input, and these headers are for setting the gain and disabling channels. Now we're only going to be using a single channel, so I've terminated both the RF input and the IF output for the second channel. And since we're using test equipment, we have these 4-to-1 balance. Normally the IF is a 200 ohm differential output for driving things like pre-ADC filters and keeping distortion very low. But again, since we're using test equipment here for evaluation purposes, we have a 4-to-1 balance to bring that down to 50 ohms. These headers over here are for setting the gain as well as disabling individual channels. Now since again we're not using the second channel, I'll go ahead and disable that and we'll see the current drop from its current setting of about 225 milliamps down to about 127 milliamps. Obviously that will change once we apply signals, but you get the idea that there is roughly a 50% power savings by disabling a single channel. All right, so with everything connected, I have my two synthesizers. This is connected to the RF input, this is connected to the LO input. I'll set the RF to 1000 megahertz and the LO to 800 megahertz. I've got my spectrum analyzer set to a center frequency of 200 megahertz to capture the IF output. Now these are uncalibrated, but they're both set to about plus 6 dBm. It's as low as they'll go. And the gain settings on the eval board haven't been changed, so that should be sitting at about 11 dB. So we should see a signal somewhere around 17 dBm here. So if I turn my RF outputs on, we have our 200 megahertz signal and it's sitting just under 17 dBm. Now I can go ahead and change the outputs to 3600 megahertz to kind of go to the opposite end of their range. 3800 megahertz on the RF. Turn those back on. And of course we don't change the spectrum analyzer because we're still at 200 megahertz. And you see that our signal has dropped just slightly, but to cover that range with a pretty flat gain across the entire spectrum, and we didn't change anything on the BOM. That's one of the really impressive things about the Versa Mixer. Now, what's not apparent on here is if we change the gain, and we can do that by shorting some of these pins together. If we go ahead and reduce this gain, what you don't see is that noise figure stays very, very flat. So even though we dropped the gain from about 11 dB to, I think the minimum setting is 2 dB, the flat noise technology that IDT has developed keeps that noise figure very flat. And also the zero distortion technology maintains that very, very low third order intermodulation distortion. IDT's Versa Mixer family is just one example of the products in IDT's RF portfolio. In addition to zero distortion and flat noise, IDT offers additional innovations across their RF portfolio, including constant impedance, constant linearity, and glitch-free operation. For more information on Versa Mixer and other RF products, visit IDT.com. Okay, now we're back and we have some questions from the audience. So this viewer writes in and says, for your mixers, you mentioned that you can cover 400 to 3800 megahertz with a single BOM, low power consumption, etc. I hate to be the skeptic, but what's the catch? There's always a trade-off somewhere.
IDT's Versa mixers have extremely wide bandwidth. As you see on the slide, the RF bandwidth is from 400 megahertz to 3800 megahertz. The IF bandwidth is from 50 megahertz to 600 megahertz. And the LO bandwidth is from 400 megahertz to 3600 megahertz. Now this is the widest bandwidth mixer from IDT, and we are able to provide you this bandwidth for LO, RF, and IF frequencies with the same bill of material. You do not have to change any external components. Now, in terms of the trade-off, effectively, there are a lot of benefits of this. The only trade-off that we have is the noise figure. We have some products which have 2 dB noise figure, whereas the noise figure of our Versa Mixer family is 8.7 dB to 10.7 dB. So depending on your requirements, whether you would like to have a device with broad bandwidth, using the same device for multiple systems without changing any extra BOM components, and if you can accept 8.7 dB noise figure, then Versa Mixer, a family of devices, is a great solution for you. Now, if you want a narrow bandwidth mixer, you are able to get even lower noise figure of 2 dB as an example.
Okay. The next question, for the configurable gain on the Versa Mixer, what's the settling time on gain transitions?
That's a great question. This is something that we have actually highlighted as our programmable gain settings. So we have 4 programmable gain settings, and with these gain settings, we are able to provide a gain of 11 dB, 8 dB, 5 dB, and 2 dB. Now the settling time for this is extremely fast with only 75 nanoseconds. And we are able to, so this enables you to have on-the-fly programming of the gain. So Versa Mixer not only provides you the versatility, but it also provides you the capability to have programmable gain and do that on the fly.
Okay. And we have another question on the Versa Mixer. It says, what's the bill of materials like to cover the full 400 to 3800 megahertz for the Versa Mixer?
So with the Versa Mixer family of products, the bill of material remains the same in the entire frequency bandwidth. So you can have any RF frequency between 400 megahertz to 3800 megahertz, any LO frequency between 400 megahertz to 3600 megahertz, and any IF frequency between 50 megahertz to 600 megahertz, and the bill of material does not change. So this is one of the unique benefits of this family, which has such an ultra-wide bandwidth, has extremely low power as well with only 835 milliwatts, and has programmable gain. And we do all of this with a single bill of material.
Okay. The next question, do you have a 50 ohm version of the DSA?
As you saw on our slide on DSAs, we have a huge portfolio of DSAs. These DSAs have impedance of 50 ohms as well as 75 ohms. So 75 ohm DSAs are for the CATV market segment, the F1975 and F1977. And then we have the 50 ohm DSAs, which have an attenuation size of 0.25 dB all the way up to 0.5 dB, and the attenuation range up to 31.75 dB. So we offer both 50 ohm DSAs as well as 75 ohm DSAs, and all of these devices are in production.
Okay. And the next question is on the flat noise technology. It says, I'm just curious how you're able to keep your noise figure flat as you reduce gain.
With IDT's unique technical innovation of flat noise, which we showed you in the presentation, as you reduce the gain of your amplifier, IFVGA, the noise figure does not degrade. So noise figure, being a figure of merit of the device, remains constant with reduction in the gain of the device. Due to this, we are able to provide benefits to system designers to have constant signal-to-noise ratio in the system even when they are reducing the gain. So this is one of the key benefits that we offer with our flat noise technology. So we are able to provide you this benefit due to this unique technical innovation that IDT has, which is patented, and that's our flat noise technology.
Okay, and for the Versa Mixer, what is the isolation between channels?
We are able to provide you an isolation for the dual channel Versa Mixer, we are able to provide you an isolation of greater than 45 dB between the channels. So this prevents any interference between the channels and enables you to provide the product, a mixer with great performance.
Okay. For the constant impedance switches, what are insertion loss and isolation like at higher frequencies?
So with our switch technology, we talked about KZ, or constant impedance, where we keep the impedance constant as we switch between ports. With this technology, we are able to provide you an insertion loss of about 0.41 dB at 2 gigahertz, and we are able to provide you isolation of up to 74 dB. So as you see, we are able to provide you a very low insertion loss and great isolation in our switches, and doing that with our unique IDT's technical innovation of KZ, constant impedance, where we keep the impedance the same, and you get the benefit of no degradation and return loss, and you get the benefit of ensuring that your downstream devices do not get damaged at the point of switching due to change in return loss or VSWR of the system.
Okay. And the final question, are samples available for the F2914 switch?
All the devices that we have shown in this presentation are in production and are readily available. They have all the unique innovations that we covered during the presentation, with our switches having constant impedance, with our DSAs having glitch-free innovation, with our mixers having zero distortion. So we showed you during the course of this presentation a complete portfolio of devices using the technical innovations that we covered.
Okay. All right, and as a reminder to our viewers, those who had questions that weren't answered will be answered by email. And again, I would like to ask you to fill out the survey and provide us with your feedback. Thanks for joining us today, and thank you, Baljit, as well.
Thank you.